Hello, Mr. Jihad, how are you? I hope you're doing very, very well. So now I'm going to explaining the questions. So for question 1, cyclic cyclic codes, in error detection and correction. Cyclic codes are a type of error detecting and error correcting code that is widely used in data communication and storage systems. These codes have a special property: cyclic shifts of the data bits result in valid codes. Error detection. Cyclic redundancy check (CRC) is an example of a cyclic code used to detect errors. It works by dividing the message polynomial by a generator polynomial and appending the remainder as a check value. Error correction. Some advanced cyclic codes like BCH codes can correct multiple errors by determining determining the error positions. And then I'll go to part B, concept of redundancy. Redundancy is the sorry for that. I'm so sorry. Concepts of redundancy. Part B. Redundancy is the addition of extra bits of information to a data message to help detect or correct errors during transmission. Purpose: ensure reliable communication over unreliable channels by enabling error detection or correction. Types of redundancy: parity bits: add one bit to a data block to ensure an even or odd number of 1s. Then check some of the data blocks transmitted along with the data. Cyclic redundancy check (CRC) divide this data by a predefined polynomial to produce a check value. Cyclic, and then I forgot to tell you that. And I'll go to part C, cyclic redundancy check (CRC) process. CRC is a method for detecting errors in digital data. It involves the following steps. So we have the sender side, and receiver side. So sender side, append a number of zeros equal to the degree of the divisor polynomial to the data word. Perform binary division of the data word by the divisor generator polynomial. Append the remainder of the division, called the CRC, to the original data to form the code word. Then I'll go to receiver side. Perform the same division of the received code word by the divisor. If the remainder, syndrome, is 0, the data is considered error-free. This method is highly effective at detecting burst errors. And then I'll go to question 2. For question 2, we have two types of errors. First one is burst error. So burst error in network communication. A burst error refers to the multiple bits being corrupted during transmission occurring in a consecutive sequence. Understanding this concept is crucial for designing error detection system. So you have checksum that I have also explained it, and cyclic redundancy. So I will explain it: error types and correction. Mechanisms. This question highlight different types of transmission errors and the additional bits of or protocol required to detect or correct them, emphasizing the concept of redundancy. And I'll go to question 3. Okay, for question 3. So a single bit error occurs when only one bit in a data unit is altered during transmission. For example, a 0 might be changed to a 1 or vice versa. These errors are common in systems with a low noise and usually easier to detect and correct using error detection techniques. A burst error occurs when two or more consecutive bits in a data unit are altered. For example, 10110101 might be received as 1001101, where multiple bits are incorrect. Burst errors are more challenging to detect and correct, especially in environments with high levels of noise or interference. And part B, concept of error detection and correction. The process of identifying and fixing errors in transmitted data involves the addition of redundant bits to the original data. This process is known as error detection and correction. Introduction to error detection and correction. Error detection and correction techniques ensure reliable communication over noisy channels, since data can be corrupted during transmission due to factors such as electromagnetic interference, attenuation, or signal distortion. Adding redundant bits allows the receiver to check the integrity of the data and correct errors when necessary. And then I'll go to question 4. Okay, this is question 4. To determine whether the received word is corrupted, the parity bit is checked is an even parity method. The total number of ones, including the parity bit in the word, must be even. If this condition is not met, the word is considered corrupted. For example, received word 10110110, 7 bits. Count of 1s for even. The word is not corrupted because the parity matches received word 101101, 7 bits. Count of 1s 5 odd. So the word is corrupted because the parity does not match. Correct codes using the simple even parity method. Introduction to the even parity method. The even parity method is a simple error detection technique where a parity bit is added to the data to ensure the total number of ones is even. If the received data violated this rule, an error is detected. So thank you so much for listening, Mr. Jar. I hope you like it, and thank you so much. Have a good day. Goodbye.